Hi, welcome to this video tutorial in which I'll be explaining the binary search algorithm. Now what I'm going to do first of all is go through the steps of the algorithm, and then I'll go through a practical example of how to apply the algorithm. So first of all, what you've got to do to apply the binary search algorithm in the first place is you've got to sort the items that you want to search through. So I'm going to sort the items to be searched, and that is a really important thing to do before you try to apply the binary search algorithm. Next, what we've got to do is we've got to imagine that this is these are the items that we're searching through, and we've got in some data structure we've got some data and we've got an index. So this is item number 1, and item number 1 happens to be 2, and this is item number 2, and item number 2 happens to be 3. I've just started the index at 0 and 1 until we get to index n. And what we've got to do is first of all is do index 0 plus index n divided by 2, and this should give us the index of the midpoint of our list here. And we might have to round this up to get a whole number. And the actual numbers that you're going to be using here when you're doing this calculation are the numbers of the index. So say our list was 10 items long. This would be 0 because we're at index 0, and this would be 10 because we're at index 10. Okay, so plus round if needed. So what we then got to do is the index that we get from this calculation here, we've got to compare the value that we're searching for with the data at that index. And then we've got a choice. If the data at this index here is the data that we're searching for, the search is complete because we found the index that the search term is stored at. However, if the search isn't complete, so if the search term is not found, we have to check whether the search term is greater than or less than the data item at this index here. Then what we're going to do is if the search term is greater than the data item at the index I0 plus IN over 2, we've got to delete the first part of the list. So if the search term is greater than the data at the index I0 plus IN over 2, then we delete the list up to and including the data item at I0 plus IN over 2. And then what we do, if this is the case, if it's greater than, is we repeat steps 2 to 4 with the new list that we've got, with the list that's remaining after we've deleted that part of the list. So if the search term is less than the data at I0 plus IN over 2, then we do the same as 5, but instead of deleting the items up to and including the item at I0 plus IN over 2, we delete the item I0 plus IN over 2 and all the items after that. So we're left with just the items up to I0 plus IN over 2 in our remaining list. And then what we do is we repeat that process for the new list until we find the item that we're looking for, or until we've searched the entire list. Okay, so now I'm going to show you a practical example of how to apply the binary search. So what I'm going to do then first of all is sort the list. As you'll notice, it is not sorted in alphabetical order, and to perform a binary search you need to have your list sorted. So that's what I'm going to do first of all. Normally in a program you might use a particular sorting algorithm to do this, or you might use an inbuilt sorting function in your programming language of choice. However, in this example I'm just going to sort it by inspection. Okay, so I've got my sorted list below here, and what I've first got to do is I've got to think of this as as if I'm in a programming language and I'm storing this, say for example, in a list in Python, and this is going to give me some indexes for each item in the list. Okay, so I've written in my indexes for each item in my list. So we've got the data above and the indexes below. And what this allows us to do is do the first part of the binary search algorithm. So what we've got to do for that is look at the first index here, and this is going to be 1 in this case, and look at the last index, and it's going to be 6. And we're going to add them together, so 1 plus 6, and divide them by 2. And that gives us 7 divided by 2, or 3.5. And we've got to round this to a whole number for it to be useful in this particular circumstance. So 3.5, if we round this to a whole number, we're going to get 4. And what this tells us is this gives us a list item to inspect to see if it is the one that we're searching for. And I'm going to say that in this binary search I'm searching for the number 15. Okay, so we have to inspect the data that's at list index 4 first of all. So at list index 4 we've got 7, and 7 is not 15. So what we do is we say, well, is 7 less than 15 or is 7 greater than 15? And 7 is less than 15. So what we do is exclude the part of the list that is less than 7, essentially, because we know that 15 can't be less than 7. So we know that 15 can't be in this part of the list here. So we're going to exclude list items 1 to 7. So next off, we take our remaining list. We take the leftmost index, and that's going to be 5. And we take the rightmost index, and that's going to be 6. Add them together and divide them by 2. And in this case, we get 11 over 2, or 5.5. And if we round 5.5 to a whole number, we're going to get 6. And this means that we've got to inspect the data item at list index 6. So if we look at the data item that's at list index 6, it's 15. So we've found 15. And that's how you perform a binary search.